When you guys are like talking, like as background people, what do you guys, are you guys saying anything? What are you saying?
How's it going, though? What's going on?
Mr. Townsend, is it just the one page that is 110? Just the front and back?
That sounds
I
right.
think so. We just have
Is 110?
Mr. Townsend, is it just the one page?
Yeah, should be. There was a FRQ on the front and an FRQ on the back.
I wasn't here last week, so I have my circuit. Can I
Okay, yeah.
Did we do it? Oh, I see velocity. Okay, that's the one we did last time.
Sorry.
Simon.
I was gonna say I've got their eye on me, but they kind of. I don't think so.
Alex.
I don't think it's. Well, I'm just looking at like children or like. I saw like something about how like some of them really aggressive girls in classes that like throw them away.
Thank you.
So they don't like.
Okay, good morning, or good afternoon. Good afternoon. There is one assignment that I would like from you guys. A lot of people are asking. I'm pretty sure it's just one page. The 2 practice FRQs we did last class should be numbered as 110 for you. So if you did not see that under bell work, please make sure your name's on it and come bring it to me. So we're going to do pretty similar to what we did last class, where I've got 2 practice FRQs for you that have to do with AP review. So topics you have not used or thought about recently. Also, like we did last class, I will set the first timer for you, and I will go over the scoring and kind of highlight some of the stuff that I think shows up frequently on these types. Then I'll have you do the back one, but both of these are the same type. Not the same type we did last class, but they're the same type of FRQs. And then once you're done with that, the second half of class, or roughly the second half of class, in your binder last class, I asked you to do the FRQ on the back of 107, and I asked you to start looking at the front of 107 to remember what topics are considered Unit 8 and what those topics will be on your next test. There's only like 4 or 5 topics there, but you need to go through there and make sure I'm good with this, not good with this, need more practice with that. And I'm giving you about half a class to do that and hopefully get a little bit of practice in. So that's the plan for class this morning. So is there any questions about any of that stuff before I ask you to try the first FRQ? Okay, so I'm going to set a 15-minute timer. So this is FRQ 3 from 2019, FRQ 3 from 2020. Do the 2019 one first, please. It's on the front. So 15-minute timer starts now. Try to remember some of your pacing positives or negatives from last class and try to apply those on this one. I will also say, I'm trying not to interrupt you too much here, but just like last class, the first FRQ, probably was a little rougher for you than the second one, because again, this is some stuff from first semester that you maybe not have thought about as much. So the front one will probably be a little lower for you, and then the back one hopefully goes a little bit smoother for you because you'll have remembered some of those things. So just do the best you can. stop. Perfect timing. Okay, so it looked like some of you guys are still working on this one, and again, that's okay. It's not that you can't spend more time on the AP exam, it's just that you get 15 minutes on average. So if you need more time, you'd have to find that time somewhere else. So before I pull up the scoring here, so again, I'm trying to show you the same thing as last class. I'm trying to show you that this type of FRQ is commonly asked. Again, this first one, without any hints, reminders, or anything like that, I suspect there's several things you may not have thought to try, or some easy points that you could have possibly gotten. But I need you to know that this is commonly asked. So once we score this one, you take a few minutes, try to learn from your mistakes, and then you practice the back one, which is similar, not the same exactly, but the same type. You have a good understanding of if you're ready to go for this type of FRQ or not. But these are referred to as graph analysis questions. So if you even just scan the back, you can see it has a similar type of graph as before. So again, to convince you that graph analysis questions will probably be on this year's AP exam, remember on our class website, I've got a place that says FRQ database, so if you know that you need to practice more of these, if we don't end up taking more class time, you can go there. You can go to the graph analysis tab on the bottom, and I've got it pulled up right now just to show you. I've not put 2024 stuff on there, but it was probably on there last year. It was asked in 2023, 22, 21, 19. Why isn't 20 on there? COVID. Right, COVID was a very different year. The whole COVID test was like 2 massive FRQs, like 45 minutes each or something. 19, 18, 17, 17, 16, 15, 14, 13, 12, 11, 10, 9, 6, 4, 3, 2. So they like to give this type of FRQ. Again, I can't promise you that. You will see that again this year, but it's a pretty safe bet. Okay, and then what makes this a graph analysis question, before we look at the scoring, is at some point you had to find the area under these curves, and they didn't give you a function to do the antiderivative of. You had to use some geometry formulas. So again, if you didn't think of this, then you may not get any points on this side. But it's an easy thing to fix. So right here from -2 to 1, how much area did that have?
1.5.
Okay, that's a half. So it's a triangle, 1/2 base times height. How about this area? Well, this is like, well, let me come back to that one actually. Okay, where is it hitting on the x-axis right here? Okay, it looks like it's at a half, right? How can you know for sure? Because just guessing that it's at a half, 9 times out of 10 is going to make you miss a point. So, right, so if you see it's going up 4 to go right 2, that means the slope is 2. So it's going up 2 to go right 1. This is definitely at a half. So that means you could have done area of a triangle right here, 1/2 base times height. Again, it's a little bit harder, but what'd you get for that? 3/4. Well, it can't be positive 3/4. Okay, it's below the x-axis. Did you guys get -3/4? I'm just trusting you. Okay, and then this is a triangle, so 1/2 base times height. So again, 1/2, base is 1.5, height is 3, so you get what, 9/4, like that. Now, it's not, again, I haven't showed you the scoring yet, so I just know that we're going to need this information for this graph type. You don't have to like put these areas in the figure like this, but I think you'll see if I come back and refer to this, it's kind of nice to remember what each of these are without having to rework them some. Okay, and then this one, they said this was a quarter circle. So if you imagine this being a full square, it would be a square, well, what am I doing? I don't need to go that far. The square would be 3 by 3, right? So it would have an area of 9. So if this whole thing was under the function, the area would be 9. But how much did I not want to include? How do I find this area? One more time. Right, it's a fourth of a circle. So if you weren't sure it was a fourth of a circle, doesn't it say it somewhere in the question? Yeah, quarter of a circle. So pi r squared gives you the area of a circle. So if it's a quarter circle, it's a fourth of that. So you had to do a little bit more digging there, but this ends up being 9 minus 9 pi fourths. Does that sound okay? Okay, so again, when we move on to the second one, if you did not think about finding these areas and or you did them too quickly, then that's something that you're going to need. Okay, so now we can look at the scoring. So part A, let's talk about the scoring, and then I will give you some tips that I think could have made the questions easier for you. And I'm going to focus not on tips for every single part, but just the parts that I think they're likely to ask again. So the easiest thing to check for part A would be your final answer. You needed an answer of 9 pi over 4 minus 4, or anything that's equivalent to that as far as arithmetic. So I don't know how you would get 9 pi over 4 minus 2, but that's the same thing. So if you had something equal to that, that would be fine. If you were not sure if your answer is equivalent, type your answer in the calculator, get the decimal, type in 9 pi over 4 minus 4 as a decimal. If they're the same decimal, then if they're equivalent, you just wrote it differently. Okay, they gave 1 point if you figured out integrating from -2 to 5. So if we don't know what f of x is, how are we supposed to know what is it asking for here? How are you supposed to extract that information? Right, integration visually looks like area under a curve. So it's asking how much area was there from -2 to 5. So from -2 to 5, you needed to add all this stuff up. So you could have said 1/2 minus 3/4 plus 9/4 plus 9 minus 9 pi over 4. That is fine. That's all arithmetic. Now again, notice how quickly I answered that because I wrote down the areas here pretty quickly. Or I wrote them in the spots that they correspond to. So does everybody see? That's the area from, was it -2 to 5? Okay, so they gave you a point for that. Now they kind of, okay, so you get a point if you did that. Now they simplified quite a bit of that to, if you combine this junk together, it must come out to be, these three must come out to be 2. So 6/4 would be 3/2 plus 1/2 is 2. Yeah. So they just simplified. So again, this or anything arithmetic, I can't say that. Arithmetic, okay, I'm not going to try. If it's equivalent in just arithmetic, so things like f of 1 is not arithmetic. When you integrate something and you've got to evaluate it from something to something, that's not arithmetic. You've got to do those parts, but you've got something equivalent to that. But if you had trouble starting part A, if you had why in the world is it asking about -6 to -2, notice it didn't even show you that in the picture. So that's not a typo. There's not going to be any typos on your AP exam. They field test these questions quite a bit. They were asking from -6 to -2, how much area is there? Well, the first statement tells you that the area from -6 to 5 is 7. So if this to this is 7, and we know how much this is, it was 2. I'm just still in their answer. Does that make sense? You guys see my logic there? If the whole thing's 7, that's what they told you in the first statement, and then you can calculate this, then you can just subtract those to find this. This stuff plus this stuff is supposed to equal 7. So, in fact, you had to say something that showed that you understood that relationship. There's a chance that some of you might have understood that relationship and didn't put pencil to paper. I'm not saying this is the only way to get the point, but you needed something to show that the area from -6 to 5 is the same as the area from -6 to -2 plus the area from -2 to 5. This you can do by hand. This part was given in the question. It was 7. And then you've just got an equation. 7, subtract the stuff you can find by hand, leaves behind the stuff that they were looking for. Okay, so I think there's a lot going on there. Is there anything you want to ask about part A? Anything you want me to say again? Okay, you feel like you can do that if you see it again? Okay. All right, part 2. Evaluate, integrate 3 to 5 to f prime of x plus 4. So they took the question here. They split it into 2 integrals. So here's the plus 4. So 3 to 5 of 4 and 2 times the integral 3 to 5 of f prime. Now, to be fair, they didn't tell you anything about f prime. But what is the antiderivative of f prime? F, right? The thing you can take the derivative of to get f prime is f. So that's why they have f of 5 minus f of 3. They're evaluating it from 3 to 5. They plugged in 5 into the antiderivative, plugged in 3 into the antiderivative, and subtracted those. That's one of the fundamental theorem of calculus. You have practiced more taking the derivative of an integral, but you also need to integrate a derivative like that. This is just more intuitive to me. If you were careful, the thing that you need to take the derivative of to get f prime is f, but it needs to be evaluated from 3 to 5. So 1 point there and 1 point for the answer. So if you got 2 plus 2 square root of 5 or anything equivalent to it in arithmetic, yours is fine. Again, if yours looks wildly different, I can't tell you at an instant. I'm not a human calculator. You have to type in 2 plus 2 square root of 5 in your calculator, look at its decimal, type in your answer, look at its decimal. If they're the same decimal, then it should be fine. If they're different decimals, then they're not equivalent. Okay, or to me this looks a lot like the same process, but they gave some other suggestions there. But 2 points for part B. Okay, part C, find the absolute max on the interval -2 to 5. So without even looking at their scoring, as soon as they say absolute max or min was one of our theorems from last semester. It's not mean value theorem. It's not intermediate value theorem. What's another word for absolute? Extreme. And even though you don't notice this scoring, you don't have to say anything about extreme value theorem, but extreme value theorem is your shortcut to test the endpoints, and any time it crosses the x-axis. So these would be like the critical numbers. So if somewhere in your work you showed that -1 is a possibility, you get a point, even if the rest is wrong. You needed to use, so this was about G, but they gave you the graph of F. So I know you had to do this. I would suspect some of you didn't write this down, but the derivative of g is the same thing as f. Take the derivative of the left side of that equation, the derivative of the right side, taking the derivative of an integral where the bottom's a constant, the top just gets to get plugged in. That's a different form of the fundamental theorem of calculus. And then finally, find the absolute max. So that was this. That's the biggest value. And then what about justification? Where in their work do they have the justification? All right, the table. This is called a candidate's test. A candidate's test is a very efficient way to justify your answer. I tested all the important stuff, also known as the endpoints and the critical numbers. So that's why, because otherwise you need to explain, why didn't you test x equals 2? Why didn't you test x equals 3? Why didn't you test x equals 2.5? Short of using the candidates test, you need to explain all of that, which you probably would not do. Okay, and then probably the part that you thought was one of the harder parts, well, I don't know. I think students are usually intimidated by part D, but it's actually not too bad. It's a limit question. So limits, you should always try to do direct substitution. Notice they got 10 to the first minus 3 f prime of 1 divided by f of 1 minus arctan of 1. So is 10 to the first arithmetic? Yes. So you could leave that 10 or 10 to the first, that's fine. 3 times f prime of 1. F prime of 1 is not arithmetic. You have to figure out what this is. Remember, derivative means slope, so you just had to go to your graph. When x is 1, he has a slope of 2, and that's why they put a 2 there. Times negative 3 is arithmetic, divided by is arithmetic, 1 minus is arithmetic. What about arctan of 1? Did you guys get that that is pi over 4? Okay. I was surprised by this, but this is good that they make us do this training. They consider arctan of 1 arithmetic. So if you stopped right here, it's correct. If you tried to simplify arctan of 1 and you did it incorrectly, then you lost the point. So arctan of whatever, arctan of 0, arctan of 1, arc cosine of 1, that's considered arithmetic to them. So unless you are sure, there's really no point in risking getting it wrong. So, but only 1 point for that. So, as I said, this one should probably come off pretty rough. Again, we haven't talked about this type of thing in a while. Extreme value theorem was from last semester. Talking about integration as area under a curve has been since the very beginning of the semester. But this is what's called graph analysis, and what is consistent about those is you can find the area, and you need the area of some of those parts using geometry formulas. Either area of a triangle, area of a triangle, area of a triangle, area of a circle, area of a semicircle, area of a quarter circle, all the basics to kind of piece that together. Okay. So remember, before you move on, this is the most important part. So I insist that you do your corrections in a separate color. So if you didn't do that as I went over it, there's a link there at the top, so you can pull that up on your Chromebook and go straight to that. If you need to borrow a colored pen or pencil, I've got a whole tray of them. Always help yourself. Just please put it back so that it's there for you next time. But then take a few minutes, catch your breath. You just did your best that you could on an FRQ, and then I just threw a whole lot of information on you. So catch your breath, but try to absorb some of this. So if the next FRQ asks you the exact same things, feel like you could get a 7, 8, or 9 on it before you flip the page. Now, I'm not going to set the timer for the next one because some of you, if you did great on this one, maybe you don't need to spend any time reviewing it or very little time doing corrections. If you really struggled on this one, you need to do more corrections. You probably need to think about and look at and study it a little bit more. So that's why I'm not going to set the second timer. I will let you do that. So when you're ready, you can set a 15-minute timer, try the one on the back, And again, it's not going to have the exact same things, but it's the same type of FRQ. So some of the important approaches are going to carry over, and you should feel better about the second one. Maybe not great, but you should feel better about the back one. So. Also, all things considered, these tend to have a little bit lower average, it looks like. The one you just did had an average of 2.7. Again, remember, that's students who took it at the end of their AP review, after they studied before the AP exam and such. So if you're close to 2.7, I think you should be happy with that. And then the one on the back is only 2.07. So students found that one to be a little bit harder, but there's a good chance you might think it's easier. So anyway, so I will get out of your way there. If you would like some help, if you'd like me to go in depth more with you on the front FRQ, I would be happy to. You just need to let me know. Otherwise, I've got the agenda back up for the rest of the class here. So do the back FRQ. Score it. Do the corrections on it. And then that should be about half the class when you finish up with that. And then with the second half of your class, page 107 in your binder doesn't have questions that you have to fill out on the front side, but it reminds you what is going to be tested on Unit 8 when we get there eventually, and extra practice opportunities. So figure out where you stand on that and maybe get some extra practice in before you leave. Not anything that you have to turn in to me, but I'm giving you some class time to do that. Again, we still have that Unit 8 test, and I will warn you before it shows up. So I will warn you the class before it hits. But it will not be next class, I can promise you that. Yep.
Would this count as a reason for, that I know that 5 is the most value? Because I said that it's because it's the most area under the graph for the positive value, because I thought it was obvious, the graph given. Would that be enough to get the point? Would I have to do the...
Well, you say, the way you said, because it has the most positive value. Okay, now how do you know that?
Because on the graph it's on the top side.
So you're telling me because it has more area. How do you know it has more area?
It'll explain it like bigger than the smaller.
How do you know it's bigger than the small area? I'm not saying that you can't justify it that way,
Okay.
but every one of those statements, there's another piece that could be still incorrect. So the way you
Alright.
worded it, I would say no, they wouldn't give you a point. I think
Okay.
eventually you're going to get to the rabbit hole. How do you know this is more than this? The only way for you to show that you knew more than that is compare the areas,
Okay.
like they did on the scoring thing. So.
I just had a question or see how do you get this? Because I saw that on there.
Well, they're going to do the equation for G. G is what?
Negative 2 to x equal to dt.
Okay. And so you need this. Okay, so what am I doing to this to make it that? Okay, what's the derivative of this?
Or f of x.
Right. If you're taking the derivative of an integral and the bottom's a constant, you get to just plug this in. Remember doing that a lot?
Yeah.
Times the derivative of this, but in that case it was 1. That's how they knew this was equal to that.
Okay. And then
this was in the graph, so the graph then helped you with your question.
in the critical numbers or just any points like across the
Anywhere where it's 0.
Okay.
Because that's where the area stops increasing or starts decreasing. So those would be the important values. Yeah, so you really should test both of these. You really should be testing -1.5, and then for whatever reason, it lets you test, they give you a point if you should test -1, but you really should test both. The endpoint and anywhere where it crosses the graph.
Where do you plug thinking? Like, you're testing
Well, what are you trying to find the max and min of?
of G.
Okay, so. Okay, so where the max and min would be absolute max and min. Or I'm sorry, they just want so the endpoints were what, -2 and 5? But if you're trying to find the max of G, you should be plugging it into G. So, like -2, if I plug that in here, x is -2. Well, if you integrate from -2 to -2, what do you get?
Zero.
0, right? There's no area, right? If you do -2 to 5, well, that helps where if you wrote the areas on your graph, you have those pieces in front of you again, so they just carry that stuff up. And then where the derivative is 0 is where this is 0, which was -1.5. That's why those are critical numbers, because it's where the derivative is 0.
Okay.
But yeah, if you're trying to find the max of G, you need to be plugging them into G. So where this x, if you want this to be 5, this needs to be 5. So it's really asking what's the area from -2 to 5. Is that okay? Anybody else have something on the first one you want me to help clear up before you move on?